Hello everybody. So today I will present you my work about mathematical study on the relation of energy density and other parameters in selective laser sintering process of polyamide 12 and their influences on the quality of the final produced part. So here we talk about the most recent process of additive manufacturing, which used the polyamide powder to produce three-dimensional parts. So I'm Hanan Yaqoubi, PhD student in Laboratory of Applied Mechanics and Technology in INSET Rabat in Mohammed V University, Rabat, Morocco. So in my presentation, I will follow this plan. I will start by an introduction and research objective. Then I will talk about problem description and formulation. After this, I will explain the direct relationships for energy density calculation, and I will show you the effect of other parameters on energy density. Then I will present you the establishment of mathematical equations for the calculation of energy density as function of other mechanical properties. And finally, I will finish by the conclusion. So first of all, the definition of additive manufacturing according to standard AFNOR is a set of processes allowing to manufacture layer by layer by addition of material, physical objects from digital objects. So the selective laser sintering process is among the 7 technologies of additive manufacturing. It was developed in 1990 at University Texas in USA, and the materials used are in the polymers and nylon. The materials are in powder form, and the melted powder becomes supporting material. So what is the operation of the selective laser sintering process? So the selective sintering process is a manufacturing technique made with plastic and elastomer powder, which uses the 5-type structural triangle language produced by three-dimensional modelization software for building the component layer by layer until the part is complete. Using a CO2 laser beam which melts the polyamide powders by tracing the actual cross-section line after line with using scanner system. The powder is fast to solidify and finished product is allowed to cool for 12 to 24 hours, then it's extracted from the powder. So what is the advantage of the selective laser sintering process? So using this process make us able to produce functional polymer products at full density, which is eco-friendly, and we have high build rate, and we don't need any support structure, and we can produce accurate and durable plastic parts, and we have wide range of materials available with excellent mechanical properties for functional part application. So this technology is very recognized technology and well established, especially in the industrial sector, such as prototyping and manufacturing of cars, houses, etc. And in the arts fields, entertainment, medical sector, food, etc. So the major problem that affect quality of the final parts in selective laser sintering process is the appearance of delimitation and volumetric deformation, such as the curling and lateral growth, as you see in this picture. So the definition of the residual stress is the constraint without external force application. There are two types, the compression type and traction type, such as deformation and cracking, and their origins are the thermal gradients. So, in the bibliography, we found 3 different relations that can use it to calculate the value of the energy density. So, as you see, the ED is the energy density, P is the laser of the power, and V is the scan speed, and H is the hatch distance, and T is the layer thickness. In the second relation, we have just the power of the laser and the scan speed and the h distance as variables. But in the third relation, we have ED is the energy density, of course, P is the laser of the power, V is Canon speed, and the difference is in D, which is the laser spot diameters. So in the figures 2, the figures show the comparison of processing parameters for the production of the parts when we see that the changing in the parameters affects directly the quality of the final part. So here we found the first case study of the work of Franco in 2010. So in the table 1, we have the measured values in the table into curves to show the variation of the energy density with other parameters. So in this part, we will transform the measured values in the table into curves to show the variation of the energy density with the other parameters, and that was not done by Franco in 2010. So in figure 3, we have the variation of the energy density depending with the temperature, and this figure shows that the energy density is rapidly increases at 180 degrees Celsius and energy specific equal to 200 joule on meters. So as the second result of this first case study, the figure 4 shows the variation of the energy density depending with laser power, and this figure shows that the energy density is rapidly increases to 50 watt and the energy specific equal to 200 joule on meter. So after this, we have found the second case study of the work of Chalonko in 2016. In the table 2, we have the parameters values of welding of the parts have been shown in this work, and we have added the values calculated by two relations equation 1 and 2 of the energy density. So, as the result of this comparison, the figure 5 shows the trend in energy density and power of the laser and hash space, and in the figure 6 shows the comparison between two relations of the calculation of the energy density. So our work focuses on understanding the relationship between the energy density and the other parameters by establishing mathematical equations to calculate the energy density, which we'll use later in our complete mathematical model. We will use the result of experimental work which have already been carried out by varying the process parameters, namely the laser power, the scanning speed, the hatching distance, scanning spacing, and layer thickness. So the relative density model was estimated using the correlation method by MATLAB software. And here in the figure 7 shows the effect of energy density on the relative densities of the selective laser sintering process specimens made from polyamide 12, and this work of Yan in 2011. So we have used two methods, linear model and the general model cause. So here in the figure 8 we have the effect of laser power on elongation at break in 9L12, and this work is from the work of Colfide in 26, and we have found the relationship equation between these two parameters by linear model. So also here we have done the same thing. So in this figure 9 shows the Young's modulus values of the test specimens, and this work is the work of Colfide in 27. So we have used the linear model method of the two orientation, the orientation 0 degree and the orientation 90 degree. So the orientation of the parts affects the quality but also the geometric stability. When we talk about orientation, we are referring to a position on the brand path, X, Y, and Z. The part can therefore be positioned horizontally orientation 0 degree or vertically orientation 90 degree. The orientation of the parts is one of the important parameters regarding the quality of manufacturing. So here we have do also the same thing in the figure 10, which shows the fracture strat values of the work of Garfield in 27. So here we try to find the relationship equation between the energy density and stress strain and between the energy density and flow stress. And these two figures are from the experimental work of the author Cook in 2015, and we have used the linear model method. So as the conclusion, we can say that the mathematical equation obtained in this study allows us to add them to our mathematical thermomechanical model, which deals with the problem in our next work. However, this work is done to calculate the value of the energy density as function with other mechanical parameters that few authors have ever added in their numerical simulations or modeling. And this point is very important to understand the great influence of this factor on the quality of the parts produced by the selective laser sintering process. It also facilitates the optimization of the process for the users of this technology and the manufacturers of materials, the correlation method, and the most relevant method for exploiting the experimental data from previous work which described this system. And thank you for your attention, and I hope that you are safe.